This is linear algebra. This video, we're gonna show how to compute product of metric and vector. Previous video, we studied how to do the product of metric and vectors by definition. So more shortcut how to compute matrix product of metric and vectors. Okay, let's do this one based on the definition, guys. Look at this one. Here is a matrix 3 by 2, 3 by 3. Here is metric. We say 3 by 3 metric, 3 row, 3 column, guys. Here is a vector. That's column vector. 3 row, 1 column, guys. So previous video, we're gonna show how can compute product in metric and vectors. How can compute? X1 first row, 2 negative 1 6 plus X2 second column, 3 5 negative 2 X3 third column, 4 negative 3 8. That's how I compute product of metric and vectors, right? So let's do it. This one is x1 2, x2 3, x3 4. So you gotta have 2x1, 3x2, 4x3. Second are gonna be negative x1, 5x2, negative 3x3. Third row is 6x1 minus 2x2 plus ax3. That's we did product of metric and vectors. Okay, that's the definition. How can we do these steps, guys? Look at this one. How you got to this 6x1, 3x2, 4x3. Look at this one. 2x1, 3x2, 4x3. That's you're gonna do it, guys, okay? So you way to compute here, guys. 3 times 3, that's the size of metric. 3 times 1, that's the size of vectors. So this gonna be outcome of product of metric and vector gonna be 3 times, guys, 3 times 1. So 3 row, 1 column. So first row, here is the first row gonna be 2 times x1 plus 3 times x2 plus 4 times x3. That you find the first row. Okay, let's go second row. Second row is right there, here. Negative 1 times x1, 5 times x2, negative 3 times x3. That's the second row. Third row gonna be, guys, third row gonna be right here. Third row, 6 times x1, negative 2x2, plus 8x3. That you can find the third row, guys. That's how to compute metric and vector quickly, guys, okay? Let's practice product of vector and column vector, okay? So here is basically you have to check this metric is how many, the size of metric is 2 by 3. Where do you 2 coming from? How many row? 1, 2. How many column? 1, 2, 3. Okay, column vector gonna be how many, what's the size of a column vector? 3 times 1. 1, 2, 3, 3 row, 1 column. So how gonna do this? Here, guys, product of metric and vector gonna be, so first one, so outcome gonna be here right there, 2 times 1, okay? 2 row, 1 column. So first row, this one we're gonna check it. So 1 times 4 plus 2 times 3 plus negative 1 times 3, okay? Negative 1 times 7, I'm sorry, guys, 7. Let's go to second, this one. So 0 times 4, negative 5 times 3, and 3 times 7. So you have new metric, 4 plus 6 minus 7. Second row gonna be negative 15 plus 21. So answer gonna be 3, here is 6. That you have find it, guys, okay? Let's try one more time, guys. So here, what is the size of A? 1, 2, 3, 3 low. What is column? 1, 2, 2. What is vector? Column vector? 2 times 1. So our outcome gonna be, what is your outcome of metric, guys, here? 3, 1. So you expect 3 row, 1 column, guys, okay? So first row gonna be, let's go first row. This first row, 2 times 4, negative 3 times 7. That's the first row, okay? Second row gonna be 8 times 4, 0 times 7. Third row gonna be negative 5 times 4 plus 2 times 7. Okay, what is the outcome? A minus 21, 32, negative 20 plus 14. A minus 21, that's the negative 13, 32, negative 6. That's the you find the product of metric and column, okay? Next one is the property of product of metric and vectors. This is property of product of metric and vectors. Here is add the two vector, guys. Look at this one. Add two vector and you times matrix. You're gonna each product of metric and vector and add later. That's the exactly same thing. This one is product of metric and vector times scalar multiplication. And at the same time, you're gonna vector times scalar multiplication, and then you times metric, okay? That's the property of product of metric and vectors. Let's prove this property by using the example, guys. This is a metric. Can you see that? This is a 2 by 2. This one is 2 vector is 2 by 1, 2 by 1. Okay, so let's prove. First one is we're gonna try A, U vector plus V vector gonna be. So this one first, A metric is 2, 5, 3, 1. Addition of two vector, guys. Addition, 4 plus negative 3, negative 1 plus 5. So you have 2 and 5, 3 and 1. What is addition of two vector? 1 and 4. Guys, remember, how can do the product of metric and vector? So this one, 2 times 1 plus 5 times 4. Second row, 3 times 1 plus 1 times 4. So this is gonna be 2 plus 20, 3 plus 4. That's gonna be 22, 7. Does that make sense? Okay, let's try do the product first and add later. So you have to do 2, 5, 3, 1 times vector 4, negative 1 plus 2, 5, 3, 1 and vector negative 3 and 5. Okay, so how gonna do it, guys? The first one, 2 times 4, 2 times 4, 5 times negative 1, 3 times 4, 1 times negative 1. That's the second row. How about second one? 2 times negative 3, 5 times 5, 3 times negative 3 plus 1 times 5. That's the product. Then you have first one. First one you have what? A plus negative 5. That's the 3. 12 plus negative 1, 11. This one, negative 6 plus 25. That's going to be 19. Negative 9 plus 4 is negative 4. Addition of two metric, 22 and 7. Exactly same this one, right? So you're gonna say this two is same. Okay, so you're gonna do product first and addition later, or addition of vector and product later, exactly same, guys. Let's do the scalar multiplication. So let's do the A to U first. What is this one? A gonna be 2531. 2u, 2 times u, 2 times 4, 2 times -1, 2531, 8, -2. Guys, you have practiced by yourself, guys, okay? So this gonna be what? This gonna be 2 times 8, 5 times -2. 3 times 8 plus 1 times -2. So you have 6 plus -10, 24 plus -2. That's gonna be 6 and 22. That you find this product, right? So let's do the AU vector product first and scalar multiplication. So you already did right there, guys. You already did AU right there. AU is right there, right? So this one is gonna be 2, 3, 11. That's gonna be 6, 22. So you're gonna say these two things is the same. So conclusion is right there. Scalar multiplication and the product of metric, and this one, product of metric and scalar multiplication, exactly same, guys.